Ever try to walk on very slippery ice? It's tough, right? You slide all over the place. That lack of grip you feel is all about friction, or rather, the lack of it. Friction is an invisible force. It's working all around us, every single moment. When you pick up your morning orange juice, or when you tie the laces on your sneakers, friction is there, quietly doing its job. It's like an unseen friend helping us out constantly. So what exactly is this mysterious force called friction? Well, science. Friction is a contact force. It happens when two surfaces touch and try to move past each other, or when they are already moving past each other. The main thing about friction is that it always opposes motion. It's like a built-in brake for the universe. It tries to stop things from starting to move, and if they are already moving, it tries to slow them down and stop them. But why does friction happen in the first place? Surfaces might look perfectly smooth to our eyes. Think about a shiny tabletop or a polished wooden floor, but if you could zoom in, way in, with a super powerful microscope, you would see that these surfaces are actually quite rough. They are covered in tiny bumps, hills, and valleys. When two surfaces press together, these little imperfections snag and catch on each other. This microscopic ruggedness is what causes the resistance we feel as friction. Now take a moment and imagine a world with no friction at all. It would be total chaos, a real slippery mess. Your feet would just slide out from under you. You wouldn't be able to hold a pencil, let alone write with it. Cars would spin their wheels but go nowhere. Nothing would stay put. Everything would just drift around. So you see, friction is incredibly important. It's the force that helps things stay still when we want them to. And it helps us move and control our movements when we need to. Friction isn't just one single thing, it comes in different types. First up, let's talk about static friction. This is the friction that keeps stationary objects, well, stationary. It's the get-going friction. It's the force you must overcome to start moving something that's at rest. Imagine trying to push a very heavy sofa across the room. It doesn't want to budge at first, does it? That stubborn resistance is static friction working hard, gripping the floor. It's a strong force holding things in place. Once you get that sofa moving, the friction changes. Now you're dealing with sliding friction. This is also known as kinetic friction. It occurs when two solid surfaces slide over one another. Think about a child going down a playground slide, or rubbing your shoes on the carpet. Sliding friction is usually less powerful than static friction. That's why it often takes a big push to start something moving. But then it's a bit easier to keep it sliding along. Next, we have rolling friction. This is the type of friction that happens when an object rolls across a surface. Think about a bowling ball rolling down the lane, or the wheels of your bicycle or skateboard. Rolling friction is generally much weaker than sliding friction. This is precisely why wheels are such a fantastic and important invention. They allow us to move very heavy objects with far less effort. It makes transportation so much more efficient. Finally, there's fluid friction. This type of friction occurs when a solid object moves through a fluid. And by fluid, we mean a liquid or a gas. When you swim through water, you feel the water pushing back against you. That's fluid friction. When an airplane soars through the sky, air pushes against it. We often call this air resistance or drag. Even stirring thick, gooey honey with a spoon demonstrates fluid friction. It always acts to slow down moving objects. Have you ever rubbed your hands together quickly on a cold day? Go on, give it a try right now. What do you feel? They get warmer, don't they? That warmth you feel is a direct result of friction. When two surfaces rub against each other, the tiny molecules on those surfaces start to move and jiggle around faster. This increased movement of molecules is actually thermal energy, which we perceive as heat. So, friction doesn't just resist motion, it also generates heat. Friction is incredibly useful in so many parts of our lives. We absolutely depend on it to walk without slipping. The soles of your shoes create friction with the ground, giving you grip. Car tires need friction to push against the road surface so the car can move forward. The brakes on your bicycle or a car? They rely entirely on friction to slow you down and stop you safely. Even simple actions like holding a glass of water or writing with a pencil are possible because of friction. However, friction isn't always our best friend. It can also cause quite a few problems. One major issue is wear and tear. When moving parts in a machine rub together constantly, they slowly grind each other down. Think about the soles of your favorite sneakers, eventually wearing thin, or engine parts in a car gradually getting damaged over time. This wear and tear means that objects and machines don't last as long as they might otherwise. This is a big downside. Furthermore, Friction can lead to a significant waste of energy. When surfaces rub and create heat, that heat is often not useful. It's energy that's being lost from the system. This means that machines have to work harder and use more power. They need more fuel or electricity to do the same amount of work. For example, a car engine loses some of its power just overcoming internal friction. Engineers are always looking for ways to reduce this unwanted energy loss. Engineers are like friction detectives and managers. They spend a lot of time figuring out how to control friction. Sometimes they actually want to increase friction. Consider the brakes in a car or on a train. The brake pads are specifically designed with materials that create a very high amount of friction. This strong frictional force is essential for stopping a heavy-moving vehicle safely and quickly. Another example is the tread on car tires, designed to maximize grip. More often though, engineers strive to reduce friction. When friction is high, machines can wear out faster and waste energy. To combat this, they use substances called lubricants. You've probably heard of oil and grease. These are common lubricants. They work by creating a super thin, slippery film between moving surfaces. This film separates the surfaces, allowing them to slide or roll past each other much more easily. Think of oil in a car engine keeping parts moving smoothly. Engineers also choose materials carefully. Using very smooth, polished surfaces can significantly reduce friction. Beyond lubricants and smooth materials, they also employ clever mechanical designs. One of the most brilliant inventions for reducing friction is the bearing, especially ball bearings. These are small, hard spheres that allow parts to roll instead of slide against each other. Since rolling friction is much less than sliding friction, bearings make machines operate much more efficiently and last longer. So, let's wrap this up. Can you imagine what life would be like with absolutely no friction? It would be an incredibly challenging, if not impossible, world. We wouldn't be able to stand up, walk, or even hold on to anything. Cars would be useless, and even nails and screws wouldn't hold things together. Friction, this invisible force, truly shapes our world. It can be a helpful partner or a problematic opponent, but one thing is certain, our daily lives depend on it in countless ways. Science is awesome,